Today we are going to deal with indefinite integration part 6. So before we exactly get into the problems on this section, let us have a quick recap of all the formulae what we have studied so far. So these are the formulae what we have done so far. So you please go through these formulae thoroughly well and be perfect with this. And in between, if you want, you can even pause the video and just be perfect with these formulae. And we have also dealt with some special integrals last time, and these are the ones which we have done, the special integrals, and these are also the formulae to be done carefully, and you should be perfect with this. And now we have got some more special integrals this time. So that is integration of 1 upon root of x square plus a square dx is equal to log of x plus root of x square plus a square plus c. Integration of 1 upon root of x square minus a square dx, that is a combination of x square and a square with the root this time. So log of x plus root of x square minus a square plus c. Integration of 1 upon root of a square minus x square dx is sin inverse of x by a plus c. And there are some simple problems which are directly application of the formulae, and simple ones. I expect you to go through these problems also. And some more special integrals, that is x is replaced by a linear polynomial, that is integration of 1 upon root of px plus q whole square plus a square. In that case the result is 1 upon p log of, this is the x part of the problem, that is px plus q plus root of px plus q the whole square plus a square plus c. So next is this sign is replaced, that is plus is replaced by negative sign, minus sign. So it is integration of 1 upon root of px plus or minus q whole square minus a square. Then the formula is almost similar to this, only the difference is this part, that is we will get minus sign here. So 1 upon p log of px plus or minus q plus root of px plus or minus q whole square minus a square plus c. And you may find integration of 1 upon root of a square minus px plus or minus q whole square, linear polynomial. Then the result is 1 upon p sin inverse of px plus or minus q upon a plus c. Let us get into these some examples which are based on the formulae and the special integrals type what we have done so far. So in this part, what you find is, in these 6 problems, x term in the polynomial, quadratic polynomial, is missing. That means that problem contains only x square term and a constant term. Sometimes the coefficient x square may be a perfect square or may not be a perfect square, like this, and constant also may be a perfect square or may not be a perfect square. So in these problems what we find is a complete quadratic polynomial including x term. And the difference what you find is that coefficient of x square may be 1 or a perfect square or may not be a perfect square. And in the remaining these 3 problems we find coefficient of x square is negative. So let us tackle these problems one by one. So integration of 1 upon root of 4x square plus 9 dx. So here 4x square is written as 2x the whole square and 9 is written as 3 square. So that this get reduced to the form of 1 upon root of x square plus a square. So result is almost same. Log of 2x plus root of 2x the whole square plus 3 square into 1 upon 2 means we are dividing this expression by the coefficient of x, that is 2 plus a. So 1 by 2 log of 2x plus root of 4x square plus 9 plus a. So here we find 1 upon root of 4x square minus 9 dx. The only difference is the negative sign in between. So almost the result is same. Only the difference is that negative sign. So 1 by 2 log of 2x plus root of 4x square minus 9 plus c. This time it is integration of 1 upon root of 9 minus 4x square. So that is written as root of 3 square minus 2x the whole square. And this is in the form of 1 upon root of a square minus x square. So final result is 1 by 2 sin inverse of 2x by 3 plus c. And in these problems, what we find is the coefficient of x square is not a perfect square. So, though it is not a perfect square, we write it as root 3x the whole square plus 2 square. These are all the direct application of the problem formula. Rather, only the difference is we divide the expression by the coefficient of x. Here the coefficient of x is 3. So, the final result is 1 upon root 3 log of root 3x plus root of 3x square plus 4. Actually, this is the denominator of the problem part. In every problem, it will be almost the same. Here it is integration of 1 upon root of 4x square minus 5. So, that is, this is a perfect square, but this is not. So, we write it as 5 as root 5 the whole square. So, final result is 1 upon 2 log of 2x plus root of 4x square minus 5 plus c. And this is in the form of 1 upon root of a square minus x square. Both the coefficient and the constants are not perfect squares. We express this way. 5 as root 5 the whole square and 2x square as root 2x the whole square. So finally the result is 1 upon root 2 sin inverse of root 2x upon root 5 plus c. And here we have a complete quadratic polynomial in the denominator. And now we make use of the same technique what we have done earlier when we have dealt with the problems without the square root. That is, we express the denominator, a part of the denominator as a perfect square, that is a plus b the whole square format. A square plus 2ab plus b square. Now if you carefully observe it, this is a square, you can say. So 2ab, I am splitting 6 in this format. So this is a and this is b. So the square of b is 9. So 13 is written as 9 plus 4. So it becomes integration of 1 upon root of x plus 3 the whole square plus 2 square. And that's equal to log of x plus 3 plus root of x plus 3 the whole square plus 2 square. And on simplifying this, we get back the problem. So that's equal to log of x plus 3 plus root of x square plus 6x plus 13 plus c. Integration of 1 upon root of 9x square minus 12x plus 20. Again, the same technology is, the same technique is used. That is, a part of the denominator is expressed as a square minus 2ab plus b square, which is nothing but a minus b the whole square. So here, a is 3x. The role of a is played by 3x. So it becomes 2ab. So b will be 2, square of which is 4. So 20 is written as 4 plus 16. And this becomes integration of 1 upon root of 3x minus 2 the whole square plus 4 square dx. So log of 3x minus 2 plus root of 3x minus 2 whole square plus 4 square into 1 upon 3. 3 is nothing but the coefficient of x. We are dividing this expression by the coefficient of x. So 1 by 3 log of 3x minus 2 plus root of 9x square minus 12x plus 20 plus c. So this time coefficient of x square is not a perfect square. So we take it out. And that too is taken outside the square root also. And along with that we use the same technique of completing the square, that is a part of the denominator is written in the form of a square minus 2ab plus b square. So it was 3x. So we multiplied by 2, so I have to divide by 2 as well. So it becomes 2ab, b will be 3 by 2. Square of which is 9 by 4. We have added 9 by 4, subtracted 9 by 4. And 5 by 2 can be written as 10 by 4, so it becomes 10 minus 9 upon 4. So it becomes integration of, rather 1 upon root 2 into integration of 1 upon root of x minus 3 by 2 the whole square plus 1 by 2 the whole square. And that is in the form of root of x square minus a square. So 1 by root 2 log of x minus 3 by 2 plus root of x minus 3 by 2 whole square plus 1 by 2 whole square. So this gives the result as 1 upon root 2 log of 2x minus 3 upon 2. But remember, this time on simplifying this will not get reduced directly to the type of formula because we had taken root 2 out. So this is what we left with. So this time coefficient of x square is 1 and 10 is written as a 2 into x into 5. So b square is 25. that is added and subtracted. Therefore, it becomes a square minus 2ab plus b square. So 9 minus 25 is negative minus 16. So this reduced to the form of 1 upon root of x square minus a square format. So it is 1 upon root of x minus 5 the whole square minus 4 square. So that is log of x minus 5 plus root of x minus 5 whole square minus 4 square, as it is this problem part. And now that reduces to the result as log of x minus 5 plus root of x square minus 10x plus 9 plus c. So here it is integration of 1 upon 4x square plus 28x plus 13. So coefficient of x square is a perfect square. And now this 4x square written as 2x the whole square. Now this becomes a form. It behaves like a. So it becomes a 2ab. So 28 is written as a 2 into 2x into 7. So role of b is played by 7. So I am adding 49 and subtracting 49. So this gives you 2x plus 7 the whole square, and this gives you 36, rather minus 36. Minus 36 is written as minus of 6 square. And just apply the formula, and this 1 by 2 comes by the side. So the final result is 1 upon 2 log of 2x plus 7 plus root of 4x square plus 28x plus 13 plus c. There is the simplification of this is this. Now this time integration of 1 upon root of 2x square plus 5x minus 7. So 2 is not a perfect square, we take it out. So it becomes x square plus 5x by 2 minus 7 by 2. And the 2 goes outside the integration. And again we adjust, rather we can say complete the square method. We have make it as a complete the square. So it was 5 by 2x. So it is written as 2 into x into 5 by 4. Because the coefficient of x was not even, so we made it by multiplying and dividing by 2. So this becomes b. Square of b is 25 by 16, added and subtracted. And that finally gives you 1 upon root 2 integration of 1 upon, this part is x plus 5 by 4 the whole square minus 81 upon 4 is nothing but 9 by 4 the whole square, which is in the form of 1 upon root of x square minus a square dx. So that's equal to 1 by root 2 as it is log of x plus 5 by 4 plus root of x plus 5 by 4 whole square minus 9 by 4. And on simplifying this, we will get 1 by root 2 log of 4x plus 5 upon 4 plus simplification of this works out to be this, that is root of x square plus 5x by 2 minus 7 by 2 plus c. And be careful, this will not reduce to the problem part because we have taken 2 out. And here coefficient of x square is minus, negative. So if we take minus and out only from these two terms, almost all the techniques are same what we have done earlier with the similar kind of problem without the square root. And now we again complete the square. That is 6x is written as 2 into x into 3. So role of b is played by 3. So b square 9 added and subtracted. So that open the bracket, last 9 will become minus 9 becomes plus 9. And that will be 1 upon integration of 1 upon root of 25 minus x minus 3 whole square dx. 25 is written as 5 square, and now it will be in the form of 1 upon root of a square minus x square. So it is sin inverse of x minus 3 upon 5 plus c. Here the coefficient of x square is negative, but it is a perfect square, 9. But still what we do is we take the negative sign out from only those two terms, second and third term. And now within the bracket, adjust, or rather you can say complete the square. 9x square is written as 3x the whole square, and 6x becomes 2 into 3x into 1. So plus 1 minus 1. When you open the bracket, that minus 1 becomes positive 1. 15 plus 1 gives you 16. So finally it becomes integration of 1 upon root of 4 square minus 3x minus 1 the whole square dx, which is in the form of 1 upon root of a square minus x square. That is sin inverse of 3x minus 1 upon 4 into 1 by 3. This 3 is nothing but the coefficient of x, that is here. So finally it becomes I equal to 1 by 3 sin inverse of 3x minus 1 upon 4 plus c. And here the coefficient of x square is negative and not a perfect square also. So first what we do, we take 2 out. After taking 2 out, root 2 outside, we take 2 outside even from the root also, so it becomes root 2. And in the next step we take minus n out from these two terms. So 3x by 2 minus x square becomes x square minus 3x by 2, and this 2 goes outside the integration, root 2 rather. And now complete the square, 2ab format. 3x by 2 is written as 2 into x into 3 by 4. That is the point to be noted here. Careful, be careful. So the role of b is played by 3 by 4. So b square is 9 by 16, which is added and subtracted. When you open the bracket, this becomes positive. So 1 plus 9 by 16 gives you 25 by 16. Therefore, finally the problem changes to 1 upon root 2 integration of 1 upon root of 5 by 4 the whole square minus x minus 3 by 4 the whole square dx. And that is 1 by root 2 sin inverse of x minus 3 by 4 upon 5 by 4. So that reduces to finally as 1 upon root 2 sin inverse of 4x minus 3 upon 5. And now let us have a similar kind of problem, but with a substitution. We will not be having the direct application of the formula. We will have to substitute for some part of the denominator, and then the problem will get reduced to the form of 1 upon root of x square plus or minus a square, and or reverse of that, a square, 1 upon root of a square plus or minus x square type. So in this case, generally I suggest whenever you find negative powered terms, multiply and divide by opposite powered term. So the same thing I suggest here also. So using the square root, I multiply and divide by e raised to x. So next step, I will take the separate square root in the denominator. When you take the separate square root, it becomes root of e raised to x, which becomes e raised to x by 2. And now this e raised to x by 2 goes to the numerator, and it becomes e raised to x. So problem finally changes to integration of e raised to x upon root of 9 minus 4 times e raised to 2x. And now we have e raised to x, which is the derivative of e raised to x. So we put e raised to x equal to t. So e raised to x dx equal to dt. So problem changes to integration of 1 upon root of 9 minus 4t square dt. And that is written as integration of 1 upon root of 9 is written as 3 square. And 4t square is written as 2t the whole square. So that is sin inverse of 2t by 3 into 1 by 2. 1 by 2 because coefficient of x, or rather t. So it becomes 1 by 2 sin inverse of 2 e raised to x upon 3 plus c. That is, we have replaced the value of t by its original variable function, rather original part, that is e raised to x. Numerator is sec x tan x, which is the derivative of sec x. Therefore, I have to convert the denominator in the form of sec x. So I made use of the formula tan square theta plus 1 equal to sec square theta, that is identity. And when you open this bracket, it becomes plus 9. So it becomes integration of sec x tan x upon root of 16 minus 9 sec square x dx. So now I substitute a sec x equal to t. Its derivative sec x tan x equal to sec x tan x dx equal to dt. So problem changes to integration of 1 upon root of 16 minus 90 square. 16 is written as 4 square, 90 square is written as 3t the whole square. So that is sin inverse of 3t by 4 into 1 by 3. Now put back the value of t. So 1 by 3 is sin inverse of 3 sec x by 4 plus c. So here it is integration of cosec square x upon root of 4 cot square x minus 3 dx. So we know that the derivative of cot x is minus cosec square x. So directly I can substitute for cot x equal to t. So differentiate with respect to x. Cosec square x dx equal to dt. Therefore cosec square x dx, minus cosec square x dx equal to dt. Therefore cosec square x dx will be minus dt. So on substituting this in the problem, we get integration as 1 upon root of 4t square minus 3 minus dt. So this minus dt, minus n goes out. So the under root expression is written as 2t the whole square minus root 3 the whole square, which is in the form of 1 upon root of x square minus a square. So we substitute the value of t. So finally it becomes I equal to minus 1 by 2 log of 2 cot x plus root of 4 cot square x minus 3 plus c. So numerator is x square, which is available in the derivative of x cube. So we write that x raised to 6 as x cube whole square now, and then put x cube equal to t. Differentiate with respect to x. 3x square dx equal to dt. Therefore x square dx is 1 by 3 dt. So problem changes to integration of 1 upon root of 2t square plus 5 into 1 by 3 dt. So this 1 by 3 goes out, and also we adjust the denominator term as 2t square as root 2t whole square plus root 5 whole square. And now this is in the form of integration of 1 upon root of x square plus a square dx. So the result is 1 by 3 log of x part, that is root 2t plus root of root 2t whole square plus root 5 the whole square into 1 by root 2. This is the coefficient of t. So finally the result is 1 upon 3 root 2 log of root 2 x cube. T is replaced by its original variable x cube plus root of 2x raised to 6 plus 5 plus c. And here it is clearly seen that derivative of sin x is cos x. So we substitute cos sin x equal to t. Differentiate with respect to x. Cos x dx is dt. So problem changes to integration of 1 upon root of t minus raised to t plus 7 dt. And let us simplify that. Multiply the terms, and it gives you 1 upon root of t square plus 4t minus 21. Now complete the square. 4t is written as a 2 into t into 2. So b is 2. So b square is 4. 4 is added and subtracted. And this becomes like this, which is in the form of 1 upon root of x square minus a square. So it is log of t plus 2 plus root of t plus 2 whole square minus 5 square plus c. And now substitute the value of t and also simplify this. That works out to be this. So finally it becomes log of sin x plus 2 plus root of sin square x plus 4 sin x minus 21 plus c. Here also it is clearly seen that the derivative of e raised to x is e raised to x. So put e raised to x equal to t, differentiate with respect to x. E raised to x dx equal to dt. So on substitution the problem converts to integration of 1 upon root of t square minus 60 plus 34. Again a perfect, we have to make it as a perfect square, a part of the denominator as a perfect square. So it becomes integration of 1 upon root of t minus 3 the whole square plus 5 square. That is, we have added and subtracted 9 here. So now this is the result, and therefore it becomes log of t minus 3 plus root of t square minus 60 plus 34 plus c. Now put back the value of t, that is e raised to x. Therefore I equal to log of e raised to x minus 3 plus root of e raised to 2x minus 6 e raised to x plus 34 plus c. And here what we do is this log m raised to n. So x square is n, so it comes by the side here. And this x comes by the side, and because of the whole square it becomes x square. So it becomes integration of 1 upon root of 5x square plus 3x square log x minus 2x square log x the whole square dx. So from these three terms we find x square common. We take it out, and that x square is taken outside the root and placed along with the dx, because it is clearly seen that the derivative of log x is 1 by x, because I am going to substitute log x equal to t. So derivative of which is 1 upon x dx is dt. So this part becomes dt. So problem changes to integration of 1 upon root of 5 plus 3t minus 2t square dt. So here coefficient of t square is negative, and also not a perfect square. We take that 2 out, and that 2 goes outside the square root, and along with that we also take the negative sign from second and third term inside the square root. And now complete the square within the bracket, small bracket. So complete the square. That is, again it is in the form of 3 by 2. Write it as 2 into t into 3 by 4. So 9 by 16 is added and subtracted. So 5 by 2 is written as 40 by 16 multiplied by 8. So that you can add these two easily directly. And that becomes 1 by root 2 integration of 1 upon root of 49 by 16 minus t minus 3 by 4 whole square. So this is in the form of 1 upon root of a square minus x square. So result is 1 by root 2 sine inverse of x part is this, t minus 3 by 4 upon 7 by 4. So that becomes 1 by root 2 sine inverse of 4t minus 3 upon 7 plus c. Now we substitute back the value of t. So it becomes 1 by root 2 sine inverse of 4 log x minus 3 upon 7 plus c. That is the value of t is log x. Thank you.